Okay, pre-cal, we are on the last video of 4.4. I know you're totally pumped. Okay, so I need to talk to you about the change of base formula. Because I don't know if you noticed this, but in your calculator, when you push the log button, it automatically takes the log of a common log. In other words, log base 10. So when you see something like log base 12 of 6, your calculator is not going to let you do that. If you type in log of 6, it's going to take log base 10 of 6. So we need a way to deal with that, and that is called the change of base formula. So basically what it says, whatever the base is, you can write it as log base 10 of x over log base 10 of the base. So for this problem right here, we would write it as log of 6 over log of 12. For this problem right here, we would write it as log of 5 over log of 8. So if you were just to type that into your calculator, it would give you log base 8 of 5. Same thing here, you would just type in log base 10 of 20 over log base 10 of 9. So that's just a little, you're not going to need that very much in on level, but I just wanted you to see the change of base formula. Okay, and that leads us on to solving exponential equations. Okay, these can get a little tricky. So as we look at this first one, it's pretty easy. The bases are the same. That means we can set the exponents equal to each other. Okay, so this one's not bad. So negative x plus 1 equals 3. I'm going to subtract the 1 from both sides, and I get 2. So x equals negative 2. Not horrible. Okay, let's look at number 4. I've got a base of 2. Well, 64 is not written in a base of 2, but I can write it in a base of 2 because it's actually 2 to the 6th power. So as long as I can write the base, or write the number in the same base, I'm good. And then I can just set the exponents equal to each other. And then I can solve like normal. I can just divide by 3 here so that n equals 5/3. Easy peasy, lemon squeezy. Number 5, same way, I've got 1/9, but if I write this as 9 to the negative 1, then I can write it in the base of 3. So of course 9 is 3 squared, so then I'm going to multiply that 2 by a negative 1. Now my bases are the same, so I've got negative 2 equal to 2x minus 1. Can add 1 to both sides, divide by 2, and x is equal to negative 1/2. So those aren't horrible. What's going to get horrible is when we look at 6 and 7, because if you'll notice, I'm in a base of 5 here, and 32 can't be written in a base of 5. So there's a problem. When I can't have the bases the same, okay, so when bases can't be the same, we will take the log of both sides. Because remember, the beauty of an equation is you can do anything you want to it as long as you do it to every term. All right? So I'm just going to take the log of 5 to the 2x equal to the log of 32. Awesome. Okay, so now I'm going to use my power property to move this 2x out of the exponential position. So I've got 2x log of 5 equals log of 32. Excellent. All right, now what I'm going to do, I've got to get my 2x by itself, or I've actually got to get x by itself. So since all of this is multiplied together, I'm going to divide all of it by 2 log of 5 and do the same thing over here. So essentially now all I have to do is type in log of 32 into a calculator and divide it by 2 log of 5. That's all I have to do. So let's go to the handy dandy internet, and we will type in our Desmos, and we will go to our scientific calculator, and we will type in, we're going to use some parentheses here. I'm not sure if we'll need them, but we'll see. So log of 32 and that we're going to divide by, and use more parentheses, 2 times the log of 5. So I'm just going to enter 1.077. Awesome. Where was I? 1.077. I think I wrote that correctly. Anyway, that's how you do those. Okay, on number 7, same thing. 5 and 2 are not going to be written in the same base. There's no way we can do that. So I'm just going to take the log of 5 to the 5a minus 2 equals log of 2 to the 2a plus 1. I'm going to use the power property to move those exponents down into the front. Please use the parentheses. I'm going to do the same thing here. Log of 2. Okay, now there's a really ugly way to do this, and there's a really easy way to do this. So I think we're going to use the easy way, because that will make our lives much better. So what we're going to do is we're going to find the values for log 5 and log of 2 in our calculator again. So I'm going to go to log and find log of 5. Okay, it's obviously a hideous fraction or decimal. So what we're going to do is we're going to tidy it up, and we are just going to, if you'll notice, it's 0.698. So we're going to round that just to 0.7, since it's kind of hard to round it just to 2 decimal places. So 0.7 is what I'm going to put right there. And now I'm going to find log of 2. And just for consistency, we'll round it to just 1 decimal as well, so 0.3. That just made our lives so much easier, right? Okay, so you're now going to distribute your 0.7 to 5a and to 2. So when we multiply that out, of course, we are going to get a decimal. So don't freak out, because that's why these kind of get ugly. So when you multiply 7 and 5, 0.7 and 5, you get 3.5a minus, and then 0.7 times 2 gives you 1.4 because it's 14. And then I'm going to do the same thing with my other side. So 2 times 0.3 is 0.6a plus 1 times 0.3. Okay, so now we are going to subtract 0.6a from both sides. And don't freak out about this. If you're worried about your decimals, just use a calculator. It is not that horrible. So this gives me 2.9a minus 1.4. And then I'm going to add 1.4 to both sides. So I get 2.9a equals 1.7. And then I am just going to divide both sides by 2.9. So 1.7 divided by 2.9 is equal to 0.59. Easy peasy, right, babies? I'm going to let you use a calculator, obviously, on these. So you will need a calculator for your exponential equations. Anyway, enjoy. The